Hello everyone, welcome back to Math. In today's class, we are going to explore a very interesting topic, revisiting irrational numbers. So, before that, let's recall what do you mean by irrational number. Irrational numbers are the numbers that cannot be expressed in the form p by q, where p and q are integers and the q not equal to 0. And examples are root 2, root 3, pi, etc. And we have also told that what they are non-terminating, non-repeating decimals. And now we have to know about the important properties of this irrational numbers. Okay. When we add to number, let it be one number be a rational and other be a irrational number. If we're adding two numbers, our answer is going to be what? An irrational number. That means sum or difference of a rational and irrational number is always irrational. That means what? If we are adding x is a rational number, and we are having another number which is a, if it is a root x, what's the value going to be? It is going to be x plus root x, right? So here you can see that this is what, it's an irrational number, right? Okay, similarly, if you are finding the difference of two numbers, one is a rational and other number is the irrational number, if you're trying to find the difference of both the numbers, our answer is going to be what? It's also going to be an irrational number. Okay, similarly, if you're taking the product of two numbers, among that one number is a rational and other one is a irrational number, then its product is also going to be what? Irrational number. That means x into root y. What it is going to be? It is going to be x root y. This is what? An irrational number, right? And if you are dividing two numbers, among that if the one number is a rational and the other one is an irrational number, our answer is going to be what? Irrational number. Clear? Now we have to learn the theorem 1.2. This theorem is very important. If p is a prime number and it divides a square, then p also divides a. Okay, this I can explain using the next question. So now let's prove the theorem. Prove that root 2 is an irrational number. So what we have to do? We have to assume that root 2 is a rational number. If it's asking us to prove it's as an irrational number, what we have to do? We have to assume as its opposite. That is, we have to assume root 2 is a rational number. Rational number means what? A number which can be written in the form p by q, where p and q are integers and the q is not equal to what? This denominator q is not equal to 0. So here what I can write? Root 2 equal to p by q, right? Where p and q are co-prime also. P and q are co-prime means what? Co-primes are those numbers which have no other common factor other than 1. Two numbers that have no common factor other than 1 is known as a co-prime. So here p and q are co-prime means what? They both are having only 1 as a common factor. So now let this be my equation number 1. What I'm going to do next, I'm going to, on squaring this equation 1, what will happen on squaring my equation 1? I'm going to get root 2 the whole square equal to p by q the whole square, right? So how I will get this one? That is 2 equal to what? P square divided by q square, right? From here, what thing I can write? From here, I can write that 2q square, if I'm taking this 2q square to this side, 2q square equal to what? P square. This one I'm going to give as equation number 2. From here, I can write what? This 2 is what? It is p square is divisible by this 2, right? So I can write what? Therefore, 2 divides p square. If this 2 divides the p square means what? Then again I can write this 2 is again, 2 can divide p also. 2 divides p also, correct? So now what I will do next is that I am going to let p equal to 2m, where m is an integer. M can be any integer. So what I will do next? Now I will substitute this value p equal to 2m. Let this be equation number 3. I'm going to substitute that in our equation number 2. That is 2q square equal to p square is our equation number 2, right? In the place of this p, what I'm going to do? I'm going to substitute this 2m. 2m the whole square means what? That is 2q square equal to 4m square. Right? From here what I can write? That is equal to, if I am taking this 2 to the opposite side, what will happen here? That is q square equal to 4 by 2m square. Therefore, q square equal to what? 2m square. From here also what I can write? This 2. It can divide what? It can divide q square. That is 2 divides q square, right? If 2 divides q square, I can write again what? 2 divides q also. Correct? So, but now look here. This contradicts our fact, right? P and Q have no common factor other than 1, because here from both the cases, from this one and from this one, we can tell what? 2 is also a common factor of P and Q, right? Here also you can see that 2 divides P. Then here also you can see that 2 divides Q. So it means what? 2 is a common factor of both P and Q. But in our question, we started with what? P and Q are coprimes. Coprimes means they have only 1 as the common factor. So it means what? Our assumption was wrong. So how can we write that one? So here we can write, but this contradicts the fact that P and Q have no common factor other than 1. So we conclude what? Root 2 is irrational. In this way, we have to prove root 2 is irrational. Clear? Now let's do the question. Show that 5 minus root 3 is irrational. So in order to do this one, what we should do? Here our question is, we have to show 5 minus root 3 is irrational. So what we will assume here? We will assume this 5 minus root 3 is what? Is a rational number. Okay. And what's the definition of a rational number? Rational numbers are those numbers which can be written in the form of P by Q, where P and Q are integers and Q not equal to 0, right? So here, instead of this P and Q, I am going to use A and B. Okay, so how can I write this one? That is 5 minus root 3 equal to what? A by B, where this A and B are coprimes. What do you mean by coprimes? Coprimes are those numbers which have no other common factor other than 1. Okay, so here A and B are having a common factor. Only which number? 1 is the only common factor for both A and B. Clear? Now we can write here. So what we can do here, 5 minus root 3 equal to A by B means I have to isolate this root 3 in a such a way that I should get positive root 3. I will take this root 3 to the opposite side and I will take this A by B to the opposite side, to this side. Okay. That means how can I rewrite this equation? That is 5 minus A by B equal to root 3. So now I got an equation for what? Root 3, right? Root 3 is which type of a number? Root 3 is an irrational number. And what about this part? What about our LHS? In LHS you can see that our numbers are 5, A and B. These all are what? These all are integers. So when we will solve this left side, what we are going to get? We are going to get a rational number only, right? So here what is the equation? LHS should be equal to RHS, right? So now here we can tell what? This contradicts our assumption, right? Now RHS is root 3. It is an irrational number. So we have to write our step in this way. As 5A and B are integers, 5B minus A divided by B is what? A rational number. Now in RHS, root 3 is irrational number and cannot be equal to a rational number. This contradicts our assumption that 5 minus root 3 is rational. Hence 5 minus root 3 is irrational, right? So in this way you will have to wind up the answer. Clear? Now let's do the question number 1 from exercise 1.2. Here our question prove that root 5 is irrational. Whenever we ask a question like this, to prove that a particular number is an irrational number, what we have to do? Here they are asking to prove that root 5 is irrational. So we will assume root 5 as what? Rational number. And what's the definition of a rational number? Rational numbers are those numbers which can be written in the form P by Q, right? And this q is not equal to 0. So here what I'm going to do, since I assume this root 5 was a rational number, I can write this root 5 as what? Root 5 equal to a by b. Here instead of this p and q, I'm using the notations a and b is not equal to 0, right? From here a and b is what? They are coprimes. Coprimes means they both are having only one as a common factor. Okay, then what I will do, I will take this b to the opposite side. That is root 5b equal to how much? A. For this one, I am going to give it as equation number 1. Then what I will do, I will square the on squaring equation number 1. In the next step, what I will do, I will square this equation number 1. On squaring equation 1, what will happen? Root 5 b the whole square equal to a square. So it means what is root 5 into root 5? It is 5. B into b is b square. 5b square is equal to a square. From here what I can write that a square is divisible by 5. That is, therefore, a square is divisible by 5. If a square is divisible by 5 means a is also divisible by 5, right? In this way also I can write. This one I'm just giving like our equation number 2. Now what I will do, I'm going to assume a value for a now. Let a equal to 5k. So what I will do in the next step, if a equal to 5k, I need to substitute that in my equation number 1. Okay. So what I will get, if a equal to 5, this one I'm going to give as the equation number 3. Substitute what? Equation 3 in equation 1. What is my equation 1? Equation 1 is root 5b equal to a. Root 5b equal to a. In the place of this a, what I will do now? I will substitute the value 5k. Okay. In this way, after writing like this, what I will do, I will square this equation. Now, on squaring this equation, what will get? On root 5b the whole square equal to 5k the whole square. So this can be again written as what? Root 5 into root 5 is 5. B into b is b square, which is equal to what is 5 into 5? 25k square. Correct? So, right. So I can write it what? 5 b square is equal to 25 divided by 5k square. So that is b square equal to what? 5k square. Correct? So from here again I can do one thing, right? This b square is divisible by b, right? Therefore, b square is what? Divisible by 5. So here in this step what we can write? I can write b square is divisible by 5. If b square is divisible by 5, therefore b is also divisible by 5. Correct. So for this one I'm giving like the equation number 4. Now cross check this 2 and 4. You can see this is our 2. And what about our 4? 4 is this, right? As per the 2, what does it say? A is divisible by 5 and B is divisible by 5. A and B are actually what? They are coprimes. Coprimes means they only have one as the common factor, 5. Both the A and B is divisible by 5 means what? 5 is also common factor of A and B, correct? So our assumption was wrong. From 2 and 4, A and B have common factor 5, right? This contradicts to the fact that A and B are coprimes. So hence what we can tell? Hence root 5 cannot be expressed as P by Q. That is root 5 is irrational. Clear? Now let's do the question number 2. Prove that 3 plus 2 root 5 is irrational. Here also what we have to do? We have to assume 3 plus 2 root 5 is rational number. So I can write this as what? 3 plus 2 root 5 equal to A by B, where this A and B are what? They are co-primes. So here what I can do now? I can write this one as, this part I'm going to keep it here. Okay, because this is the number where I'm having the irrational number. So this I will keep it here, because since my sign is positive, I'm not moving that part. So I will just keep the 2 root 5 here and I will move 3 to the opposite side. So what I will get? I will get a by b minus 3. So this can be again written as what? A minus 3b divided by b once after taking the LCM. That is 2 root 5 is equal to a minus 3b divided by b. Now what I can do? I can take this 2 to the opposite side. So what will happen? Since it is multiplication in the LHS, so when it will go to the opposite side, it will be going to the denominator. That means it is going to do the division process there. That means put 5 equal to what? A minus 3b divided by 2 will come here. That is 2b. Okay, so now we got in our LHS we are getting this, in RHS we are getting what? A minus 3b divided by 2b, and this is our LHS. LHS is root 5 and RHS is what? RHS is a minus 3b divided by 2b. A, 3, b, these all number we know that they all are integers. So obviously when we will do the calculation there, we are going to get a rational number, right? And here this root 5, it's an irrational number. Look, this LHS is what? LHS is an irrational value. And what about the RHS? RHS is a rational value. So is it correct then? No. So what we can write? Since a and b are integers and a minus 3b divided by 2b will also be a rational number. But in LHS it is root 5, which is an irrational number. This contradicts the fact that root 5 is irrational. Hence, our assumption that 3 plus 2 root 5 is rational is false. So what we can write? If that is wrong, then it will be what? 3 plus 2 root 5 is a irrational number. Clear? Now let's do the question number 3. Prove that following are irrational. So here we have to prove that 1 by root 2 is irrational. So if we want to prove 1 by root 2 as irrational, what we should consider? We should assume that, let us assume, what we have to assume? 1 by root 2 is what? Let us assume 1 by root 2 is what? Is rational, right? Now if 1 by root 2 is rational, means we can write 1 by root 2 in which form? In p by q form. So we will write a by b, where this a and b are what? They are co-primes. So if they are co-primes, means they have only 1 as a common factor. A and b only have 1 as a common factor. So here, from here, what I can write? I need to frame an equation with root 2. I will take this root to the opposite side. So what will happen? So root 2 is equal to what? Root 2 equal to b by a. Or then what we can do? You can just reverse this. So root 2 will go to the numerator and 1 will come to the denominator. And similarly in the RHS, what will happen to the b? B will go to the numerator and a will come to the denominator if you are reversing the equation. Then that means now we got root 2 equal to b by a. If root 2 equal to b by a, this LHS is what? LHS is an irrational number, right? Root 2 is an, we know root 2 is what? Irrational. And we already know what? B and a are integers. If b and a are integers, that means what? B by a, the value of b by a is also going to be what? It is also going to be an integer. It's not a irrational number. It's going to be what? A rational number. Clear? So LHS is what? LHS is an irrational number and our RHS is going to be a rational number. So we can write what? Therefore, b by a is what? B by a is rational. B by a is rational as a and b are integers, right? So what we can write? Therefore, we can write it in this way. Therefore, root 2 is what? Root 2 is rational, which contradicts to the fact that root 2 is irrational. Hence, our assumption is what? It is false and we have to write what? Therefore, we can write 1 by root 2 as irrational. Clear? Now, let's do the next question. We have to prove that 7 root 5 is irrational. If we want to prove 7 root 5 is rational, what we should do? We should consider this 7 root 5 as rational first. So what we will do, let us assume 7 root 5 is rational. If 7 root 5 is rational means I can write 7 root 5 in which form? In P by Q form, that is A by B, where A and B are coprimes. Okay, coprime means A and B only have one as a common factor. So from here what I can do, I can isolate this root 5 here and I can take the 7 to the opposite side. So what will happen? Root 5 equal to A by 7B. Here we got our equation 1. From here what we can see, in our RHS, if you are checking, we can see which all numbers. A is there, 7 is there, B is there. These all are what? They all are integers. Therefore, our RHS is going to be what? A rational number, right? If our RHS is rational, so obviously this part should be also rational. So, but it is not happening here, right? So, root 5 we know that it's a what? It's a irrational number. This contradicts our fact that the root 5 is rational, right? So we can tell what our assumption that 7 root 5 is rational, it was wrong. Our assumption was wrong. From here we can tell, right? Here LHS is not equal to RHS, correct? In LHS we are getting it as a irrational number and in our RHS we are getting it as a rational number. So we can tell here what our assumption was wrong. So we can tell what 7 root 5 is irrational. So how we should write for that one? That is A by 7B is rational, as we know that A, 7B, these all are integers. Therefore, root 5 should be also what? It should be also rational. But this contradicts to the fact that root 5 is irrational, correct? Therefore, what we assume, it was wrong. Our assumption that 7 root 5 is rational is false. Hence, 7 root 5 is irrational. Clear? In this way, we will have to wind up the answer. Now let's do the question number 3. We have to prove 6 plus root 2 as a irrational number. If we want to prove 6 plus root 2 as an irrational number, what we have to do? We have to assume 6 plus root 2 is rational. If 6 plus root 2 is rational number, we can write it in which way? 6 plus root 2 equal to A by B, where A and B are what? Co-primes, right? So from here, I can write, I will keep this root 2 in this side itself. So root 2 equal to what? A by B minus 6. Once after taking the LCM, I can write this one as what? A minus 6B the whole divided by B, which is equal to root 2. From here, if I am checking my RHS, we can find which all numbers here? A is an integer, 6 is an integer, B is an integer. So actually what will be the result? Once after solving this part, we will get our RHS as a rational number, right? If RHS is rational, we know what? Root 2 is irrational. So this is what? This is contradicting our fact that root 2 is irrational, right? So here what we can write? Since A and B are integers, what will happen? A minus 6B by B, it is actually a rational number, right? It happened there. And root 2 should be also rational, but that is wrong. Root 2 is an irrational number. So we can tell what this contradicts the fact that root 2 is irrational. So our assumption. So what is wrong here? Our assumption was wrong. Here we assume what? 6 plus root 2 is rational. That is our wrong assumption. So we have to write. Therefore we can tell what? 6 plus root 2 is irrational. Clear? So how we had to write that part? That is, if this A, B are integers, then 6 minus 6B by B is also what? A rational, and hence root 2 should be a rational. But this contradicts the fact that root 2 is irrational. Therefore, our assumption is false and hence 6 plus root 2 is irrational. Clear? So now we have completed all the textbook questions from the chapter 1. In the next video, I will help you with some important extra questions from this chapter. That video will be uploaded next Friday. Thank you for watching Tom Math. Don't forget to subscribe and support the channel for more videos.